Yeah, good morning, students. This is the topic on bubble sort technique. So, in the previous class, we discussed about the third unit. So, just now, I would like to share my screen. So, this is week 11, lecture 1. So, bubble sort. So, this is the unit for first topics, sorting techniques. So summary of the previous unit is that in unit 3 we had a discussion on the following topics like single linked list, double linked list, and then circular single linked list, circular double linked list, stacks and queues implementation using linked list, XR lists and skip lists, and comparison of time complexities of various operations like insertion, deletion, searching operations in different linked lists. This is what we had a discussion in third unit. Now, coming to this fourth unit, in fourth unit we have two important topics. One is sorting techniques and other one is hashing. So, in the sorting techniques, we would like to discuss about different sorting techniques like the bubble sort, insertion sort, selection sort, shell sort, and then radix sort. So, the objective of this today's classroom discussion topic is that this session will develop the knowledge on bubble sort technique. So objective of this today's session is that upon completion of this CDT, students can able to develop or implement the code related to this bubble sort technique for a given data. So what is a bubble sort? Bubble sort is a very simple method that sorts the elements by repetitively moving the largest element to the highest index position of the array segment. That is when we are considering the ascending order, the largest highest element will be moved on to the highest index. If you are considering it as the descending order, then the lowest element will move to the highest index position in the array segment. So in bubble sort technique, what we are doing here is that we are comparing the consecutive adjacent pairs of elements in the array. So if the elements are not in the required order, then they are interchanged, okay, so that they will be placed in a proper way. So this process will be repeated until the list of unsorted elements are exhausted. So in pass 1, we are comparing a of 0th element with a of 1 element because these are the two adjacent elements, and then a of 1 is compared with a of 2, a of 2 is compared with a of 3, and so on. Finally a n minus 1, n minus 2 is compared with a of n minus 1. So pass 1 involves n minus 1 comparisons for finding the biggest element and positioning that biggest element in the last index of the array. So during pass 2, we are again comparing a of 0 with a of 1, a of 1 with a of 2, a of 2 is compared with a of 3, and so on. Finally, a of n minus 3 is compared with a of n minus 2. So pass 2 will involves n minus 2 comparisons and places the second highest element at the second highest index of the array. So in pass 3, again a of 0 is compared with a of 1, a of 1 is compared with a of 2, while we are comparing a of 2 with a of 3, etc. So if the elements are not in your required order, we will interchange those two elements. So finally a n minus 4 element is compared with a n minus 3. So that means pass 3 will involve n minus 3 comparisons and places the third highest element at the third highest index of the array. So like this it will be continued so that we are performing the n minus 1 passes if we have n number of elements in the array. So in n minus 1 pass a of 0 and a of 1 are compared, okay. So if they are not in the required order, it will be interchanged. So after this pass, all the elements of the array are get arranged in the ascending order. So coming to this programming part, so here we are reading these elements into the array, n number of elements, enter number of elements, n value, and then we are reading enter n integers for I equal 0, I less than n, I plus plus, scanf percentage d ampersand a of I. So this is this for loop is for reading the elements into this array. and then here we are comparing. So we are taking n minus 1 passes we are performing. So the outer for loop we will write like this: for I equal 0, I less than n minus 1, I plus plus. And this inner for loop, this is used for comparing the adjacent elements during every pass. So for in adjacent elements comparison, we have n minus 1 comparisons we are doing in the pass 1, and in pass 2 n minus 2 comparisons we are doing like that. So we are performing j equal 0, j less than n minus I minus 1, j plus plus, and then if a of j is greater than a of j plus 1, then we are swapping these two elements, a of j and a of j plus 1 elements, we are swapping by taking some temporary variable t. So this is what the nested loop we are writing for sorting of these elements using bubble sort technique. So later we are just making use of the for loop to print the elements, sorted elements onto the screen. Fine. So this is what the program is basically. Now this is a reflection spot. So what is the time complexity of bubble sort in all the three cases? So all the three cases means best case, worst case, and average cases. Anyone can answer this question? Yes, big O of n square in all the three cases. So if you are not able to answer this question, please watch this video from the beginning. Fine. So this is the time complexity of bubble sort in all the three cases. So lecture outcomes are revisited here. After completion of the session, students will be able to develop the code to implement the bubble sort technique. Fine. So summary of the session is that we started about the discussion on sorting. Sorting is nothing but it is arranging the elements either in ascending or descending order. So there are two different types of sortings are there: internal sorting and external sorting. So internal sorting is nothing but we are sorting the data which is stored in the computer's memory. Examples: the data which is stored in the arrays. So if you sort that data which is stored in the arrays comes under this internal sort technique. And external sorting means that the data which is very voluminous or large amounts of data is there which cannot be stored in computer memory. So we are going to store that data in terms of files. So when you want to sort the data which is stored in files, we are making use of these external sorting methods. So bubble sort is an example for internal sorting. So where in bubble sort consecutive adjacent pairs of elements in the array are get compared. So if the elements at the lower index is greater than the element at the higher index, the two elements are interchanged so that the element is placed before the bigger one. So this process will be continued until the list of unsorted elements exhausts. So this procedure of sorting is called it as a bubble sorting because the elements will bubble to the top of the list. So this is a lecture level practice problem. Given an array A consisting of these elements, so write the sequence of steps to sort the above elements using bubble sort method. So these are further readings on this particular topic. So thank you one and all.